This is the final chapter on this segment on algebraic fractions, 11e. So we are working to find equivalent algebraic fractions and learning how to add and subtract algebraic fractions. So this does require you to have basic skills from chapters 11, C, and D. Because here we're canceling terms. So if we look at A, you want to find the highest common factor so you can cancel them. So I know I'm going to work with the numbers first. I know that I can cancel 6 and 9 by 3, so this reduces down to 2/3. Now what I'm left with is an x and an xy. Now that x is in common, so I cross that out. So what's left is 2 over nothing, 2 with nothing next to it, over 3y. This fraction is the same as 6x over 9xy, but simplified. For B, 4a squared b over 6ac. I'm going to just lengthen this out. 4a, and b over 6a times c. Now I can simplify 4 and 6 by 2, so that leaves me with a 2 on top and a 3 on the bottom. I can cancel out an a, they're gone, and there's nothing left. So 4a squared b over 6ac is the same as saying 2ab over 3c. Pause. Do CD. I know I can simplify 24 and 32 by 8. So this reduces down to 3/4. X's cancel, so I'm left with 3xy over 4. I can cancel 45 and 81 by 9, leaving me with 5 and 9. The z's cancel, a common y cancels, and that's it. I'm left with 5x over 9y squared. So adding and subtracting algebraic fractions is the same as with normal fractions. You have to find a common denominator. So for the first example, right here, we don't have a common denominator. It's quite complicated. It's just 3 and 4. So 2a over 3 plus 3b over 4. I need to multiply this whole thing by 4 over 4 and this whole thing by 3 over 3 because I want a common denominator of 12. So 4 times 2a makes 8a. 3 times 3b makes 9b. So when I add this expression together, well, because 8a and 9b, they're not like terms, I can't combine them. You just simply write the expression out as 8a plus 9b over 12 because they have a common denominator of 12. There you go, you're done. So at this time, pause, give it a try. A is pretty straightforward. 4 a's plus 3 a's, they are like terms, so you can combine them into 7 a's over 5. B is a little more complicated. You need to have a common denominator. It's going to be out of 35. So we multiply the 3a by 7 and the 2a by 5. So 21a's plus 10a's. This makes 31a's over 35. In C, you need to have a common denominator of 12, and you're subtracting, so be careful there. So we multiply 7a by 4 and we make 28a's, and we multiply b by 3, so we make 3b. We cannot combine 28a nor 3b, so we leave it as an expression, 28a minus 3b over 12. And then finally the last one, you can work with a common denominator of 24, but I will work with the lowest common multiple, which is 12. So I multiply 10a by 2, which makes 20a, and I multiply 4b by 3 to get 12b's. I cannot combine 20a's and 12b's. They are not like terms. So I leave it as is, 20a plus 12b over 12. And of course, depending on what happens in your algebraic future, this term, this expression right here can be simplified in multiple ways. You can always break it apart into 20a over 12 plus just a plain b, because 12b over 12 just makes a plain b. You can simplify the 20a over 12 into 5a's over 3 plus b, because you can divide 20 and 12 by 4. So if you were to write this first expression on the test, that works. But if you can eventually get to a more simplified version like that, that's awesome. And of course, it depends on what's being asked of you on these tests and whatnot. And that's it.